Let's take a look at the relationship between pressure and volume of a gas. To do this, we're going to imagine that we have a container similar to ones that we've looked at before, where I've got a plunger on one end. This container is filled with gas particles, which I'll indicate as usual by these red circles here. Right now, the pressure on this gas sample is relatively low. P stands for pressure. But as we've learned previously, because gas is compressible, I can put pressure on this piston and I can push it further into the container. And what's eventually going to happen after I've increased the pressure there is that I'm going to have all these gas particles squeezed into a much smaller area. So over here, the pressure is much higher. Let's look at what happens to the volume during this change. Volume right here, relatively speaking, is pretty high. These gas particles have a good amount of room to move around in. On the other hand, the volume over here is pretty low. We've squeezed them into a much smaller space. So as pressure goes up from low to high, volume goes down. What this means is that the relationship between pressure and volume is an inverse relationship. As pressure goes up, volume goes down. They move in different directions. On the other hand, if pressure were to go down, the volume would be able to go up. You're familiar with an inverse relationship because you see this a lot with the cost of things that you buy. As something becomes more expensive, fewer people want to buy it. On the other hand, as the price of something lowers, more and more people want to buy it. So that's an example of an inverse relationship too, things moving in different directions. Pressure and volume also move in different directions because they have an inverse relationship. Let's look at how we can actually plug numbers into an equation and use this relationship to solve math problems. The relationship between pressure and volume of a gas is described by Boyle's law, which is named after the scientist who figured out what the relationship between pressure and volume of a gas was. Boyle's law can be stated that P1 times V1 equals P2 times V2. Boyle's law assumes that we have a gas and it experiences some sort of a change. Maybe we increase or decrease the pressure, change the volume in some sort of a way. So P1 V1 means that the pressure and the volume before the change multiplied together, so here we have before, equals the pressure and the volume after the change multiplied together. So let's move right into an example of a math problem that we might do to see how we can use this. I think it'll make a lot more sense. Here is a sample problem. We say here at 1.70 atm, a sample of gas takes up 4.25 liters. If the pressure on the gas is increased to 2.4 atm, what will the new volume be? So as we said before, there's a change that takes place. We increase the pressure. We now want to look at the before of the gas and the after of the gas, figure out which of these variables we need to solve for. Okay. At 1.7 atm, a sample of gas takes up 4.25 liters. So we have the before pressure, 1.70 atm, and we have the before volume, 4.25 liters. We now say if the pressure on the gas is increased to 2.4 atm, what will the new volume be? So we have P2, we have the second pressure after the change, we don't have the volume. So it's going to be V2 that we're going to be solving for. We'll want to rearrange this by moving P2 under this other thing. So we're going to get P1 V1 divided by P2 equals V2. And now let's go ahead and plug in our numbers. Initial pressure is 1.70 atm times initial volume, which is 4.25 liters, divided by the second pressure, which is 2.40 atm. Now let's take a look at how we set this up. ATM's up here, ATM's down here, which means that the atmospheres are going to cancel out. We're left with liters, and our final answer is going to be 3.01 liters. before we call it quits, let's see if this makes sense. Well, we started at 4.25 liters and we increased the pressure on the gas, which means that we squeezed it into a smaller space. So 3.01 liters is less than 4.25 liters. This makes sense that we'd have a smaller volume after increasing the pressure. Now, if you need to learn more about Boyle's law, how Boyle figured out this relationship in the first place, or want to look at graphs, or have seen something in your textbook that says P times V equals K, go ahead and look at the more complex Boyle's law video. Otherwise, you can just move on to the next gas law videos.